Okay, today we are going to talk about applying polynomial regression, and we're going to make a polynomial regression using our graphing calculator. I'm going to show you what the TI-84, if you have a different one, and 83 would be the same. Basically, we're going to do the same thing with it as you've done with finding linear regressions. So we've done a little bit of this already. I'm hoping if you have a different calculator, you can figure it out from that. How we did the linear ones. Otherwise, I guess I will show you when I'm back in class. So we're going to go through activity 1, page 359 together. So here is the data table. It says city planners are considering building a new stadium, and they're looking at traffic conditions on a major highway. Time is PM hours, average number of vehicles is in thousands. And they just say describe any patterns you notice. Well, before I graph, I notice it's going up from 1 to around 5. Maybe could be a high a little before 5 or a little after 5. I don't know for sure, but then it starts going down a little bit and drops off pretty quickly after 7. To predict the best polynomial model fit, I need to not try to just do it based off this. I need to look at the graph. So before I do 1b, we're going to do number 2, which says make the scatter plot. So I've got some graphs here that I'm going to share. And we're going to make a graph right on here. My x-axis will be time. And I'm just going to go by ones. Now notice I'm not labeling 1. I'm just going 1, label 2, 4, 3, 4. Each one is 1, but I'm only labeling half of them. I only need to go to 7. My y-axis, I'm going to go by 2s. And that is vehicles. I can't write vertically here. Labeling every other one. That's not very clear. 4 is going to be the second one. So it's 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24. And I'll plot my points. 1, 7. It's right about there. 2, 10.8. Right about there. 3, 14.5. 4, 21.1. 5, 23.9. 6 is 19. And 7 is 10. Wait, nope, that's not 10. That would be 8. 10 is here. And this looks kind of like quadratic. It could be a cubic. I know it's never going to hit 0. My guess would be over the course of a day, it's kind of probably an upside down quartic. Okay, that's my guess. We're going to look at a couple of different options, and we're going to have to pick which one is best. So we're going to go over to our graphing calculator. Hold on, I've got to stop sharing so I can actually see my screen. That's not what I want. Okay, there it is. So here I've got my graphing calculator. And I've entered all the data into the lists. I do that by going to Stat, Edit, I hit Enter, and I see that. I'm going to take a look at my scatter plot on here by going second y equals that stat plot. I will hit Enter on plot 1. I will make sure I press Enter over the on to turn it on. My X list, my data was entered in, my X data was entered into L1, my Y data was entered into L2. Mark, mine's going to be blue. I'll press zoom and go down to the 9th one, zoom stat. And looks, yeah, that doesn't look quite right for a quadratic. As I'm looking at this, it's probably more like a quartic. But I'm going to check, I'm going to do a couple different regressions, and I want to check the R squared value. R squared tells me the percent of this change in traffic that can be predicted by the hour. So I have to turn on in mine every time. Some of you might want to check this. I'm going to go to catalog. We're going to press it automatically as an alpha. So I'm going to press this D and jump to D. And I'm going to turn diagnostic on. I hit enter. I hit enter again. It says done. So now when I do this, it will give me an R and an R squared value for each type of regression. I know I'm not doing linear. So I went back to stat to do my regression. I scroll over to calc. I'm going to try quadratic, cubic, and quartic. And we'll see which one says it fits best. My frequency list is L1, L2. I'm going to store my regression equation here. I press vars, y vars function. I'm going to do y1. I get an R squared of 0.835. Okay, not bad. If I look at my graph, I will see my quadratic. That's also not that good. Now I'm going to do the same thing with a cubic. Again, X list and Y list are still all one. I'm going to store the regression equation this time. I go vars, Y vars function. I'm going to do Y2. So I'm not going to delete my Y1. Ooh, that fits real well. 0.983 for an R squared. Yeah, that fits very well. I'm going to try Cortex because I kind of would think, if you did the whole day, the Cortex would fit better. Within this data, though, this fits really well. And we're going to use the one that fits within the data best. I'm going to store this regression equation in Y3. So I'll get all three of them on the same graph. Point 985. This one fits just a hair better, actually. That one was 0.983. This one was 0.985. So I'll look at my graph. Cortex about the same. And that's probably correct. So my polynomial model, guess it's not going to show me it there, is 0.028 x to the fourth. Why won't it let me click on y3? There we go. Minus 0.854. That's going to be x cubed. So I'm scrolling up and down to get onto this, and I'm scrolling left and right to see everything. I'm going to write that out for my model. So I'll go back to the whiteboard. That's 0.0854x cubed. This will take me a second to get it all over. No, not 0.0854, 0.854. Plus 5.925x squared minus 9.5. It was 0, 0x. And then there should be a constant term as well. So that would be 11.614. So this is my polynomial model. If I sketch my equation, we'll go back and make a copy of our data. So 3 was write it, 4 is sketch it. I'm going to go back to the graph. And then 5 was how well does it fit? Well, it was a 0.98, almost 5. So it fits quite well. So if I go back to graph, it fits very well. I'll have to redo the calculation here to get the r squared. I've already started by regression equation, so I don't need to do that again. But here, 0.985 for the r squared. Okay, and we're going to answer some questions in problem 6. So the downtown is congested with more than 20,000 vehicles are on the street. Predict when the downtown will be congested. So we're going to do that by looking at the graph. So this was 20, this was 19. From about 3, maybe 3:45. This was 4 o'clock, so But 345, actually the best way to do this would be to go to Y4 and set in a 20. So it looks like about 345, 350 till about 6 is when they're predicting it will be. Okay, this is called interpolation. It means making predictions within our data range. Okay, our data went from 1 o'clock to 7 o'clock. So any predictions we make between 1 and 7 are interpolation. Okay, B says predict when the number is less than 10,000. So we'll go back to y equals and we'll put in 10. Again, because our graph is in thousands. Looks like before 2 and after 7. Uh, predict when the number of vehicles that enter or exit downtown predict the number of vehicles entering or exiting starting at noon. Okay, this is where I've got to take my equation. Okay, and noon is going to be 0. So if I look at my equation, I'm going to plug 0 in for all the x's. So I'll go back to the whiteboard here. Means I plug 0 in for all these x's. The good news is 0 is the easiest thing to plug in. And 0 to the 4th, all of these are 0. It's just 11.614. This was called extrapolation. Extrapolating means predicting outside the range of the data. So this was before the data started that we extrapolated. This one wasn't very far outside, so it wasn't too bad. The next one's not too far. It's okay to extrapolate a little bit. The last one, E, is going to be extrapolating a lot and probably won't give us a very accurate result. So I'm going to do a different color. For part D here of number 6, we're supposed to do 9 p.m. That means I'm plugging in 9 for each one. And I don't have a I guess I do have a calculator in front of me. Oh, and I'll show you the trick. There's a trick to doing this easily on the TI-84s. So I want you to understand, though, that I'm plugging in 9 for each one of these. To get 9. Part E asks me for midnight. So midnight the day before would be, if 0 was noon, midnight would be -12. And then I'll keep going. And I'll show you how to do this with the TI calculator. Okay, so we're going to quit out of this. Now, all my answers are in Y3. That's my quartic. So if I go vars function Y3 parentheses 9, this is like function notation. It's like taking f of x and saying f of 9. 9 gets plugged in for all the x's, and I get, there will be negative 32,650 cars exiting downtown. Well, that definitely does not make any sense. So see, extrapolation can lead to bad results. Models in general, sometimes we've had some where there's been negatives, negative number of people at the museum, I think on one of the last tests. Yes, those don't make any sense. So here's my midnight the night before. Oh, I hit minus, not negative. Okay, have to use the negative button, not the minus button. 3,305. Wow, that's a little surprising. Also, this would be 3,035,833. Also, probably not particularly realistic. Oops. And there my cat just stepped on my keyboard and touched my screen. So here you go. These are your predictions and the quick way to make them. Okay. Good luck with the rest of the assignment. We'll talk more about this tomorrow.